Data streaming. So the thing is, we usually work with batch data. What is batch data? Batch data means we have data already, in databases, in the hard disk. We have CSV file, we have JSON file, we have log file, we have tabular file. All these files or data, they are available, in one single file or, many files. So, but data streaming is completely different as compared to the batch files, because data streaming, they are generating at real time. So there is no storage to store them, right? And also we don't know what is the pattern of data coming and going. So we usually, are struggling with this type of data that we need to have, the proper solution for them. Since we have no data storage for data streaming, we have to consider small size of data for data streaming, like kilobytes or megabytes. So because you have to collect data from somewhere, from a source, right? And you have to process data and then, and then take action or make a decision. So how to complete these 3 steps: collecting data, processing data, and then, and apply the action. All these 3 steps needs to have done through memory. Why memory? Because memory is, let's say the fastest or the quickest hardware available, right? And we can go through to memory. So we have to learn how to do that through memory. So the things we can do over data that they are usually real-time data or near real-time. I want to give you more example about them. So usually we can do these typical analytics, correlation, aggregations, filtering, sampling. As you can see that here, we don't have machine learning. We don't have optimization. So do you know why we don't have machine learning here for real-time data? Any idea?
Because it will take time to train the model, and we won't be able to do that in a data streaming process. Great
answer. Yeah, because machine learning should be done at offline, right? Because machine learning needs time, to train data and then at the end to get, your model. So for those typical analytics that they need to take offline or let's say to take time, so it means we cannot consider them at real time. So I usually give example of Uber. So Uber is an application that you can take taxi. So let me mute all the students. Sorry, because there are some noises. I have to mute that. So Uber, just think about Uber. How does it work? For instance, you want to take a taxi. I mean, the Uber driver. So you open the application and then you want to ask Uber for a driver. So you open the application. Application asks you where are you and where is your destination. After your inputs, is going to connect you to the Uber drivers around you. So how is that possible? So it's going to collect data at real time. Those drivers, they are around you. So can you see there is no database, there is no machine learning, there is nothing about historical data. Data is generating at real time. Your location, your destination, and then driver around you. So after picking one driver, is going to calculate the distances, the payments, checkout, and many things. So at the same time, Uber is gonna to respond to your request, by sending, the distance, the time taken, the money you have to pay, and many stuff that Uber does it. So as you can see, this whole process is going to happen within a second, with less than a minute, means at real time. So for this typical work, you cannot work with like traditional Python, traditional Java, nothing. You have to learn how to manage data at streaming, data at real time. This is one example. Another example is like it's really happened in banking industries. So if I take you to trading view and then double check how Bitcoin is going on. So we as end user, so Bitcoin seems going to jump up. Okay, by the way, let's go through this one. So as you can see, this is the Bitcoin price at each hour, right? Because time scale is 1 hour. So if I change it to 5 minutes, as you can see, guys, these are live data, right? These are live data, and this is exactly this time, right? And the Bitcoin price is going to be changed, but now is really silent. But as you can see, now is 40K, something like that, and it's going to be changed. So what sort of actions usually banking industries, and financial companies they take? They usually collect this, real data, real-time data. I'm going to find out. Not alerts, not this one. Okay, and also there is another one. We call it investing is economic calendar. So, and also this economic calendar is going to give, well enough, information. And let me check. Yeah, it has yesterday. So yesterday, like we had very important news about Fed interest rate decision. So when it came up at 6 p.m. yesterday, all market has been changed. They had lots of noises, they had lots of shadows, and they had, reaction. So what do you think? How institutions take action at real time? Because at 6 p.m. there is very important news, and then at the same time there is Twitter. There is tweet from someone, from let's say USA Federal Reserve, and there is a tweet from Elon Musk, whatever, whoever, right? So just think about how to collect all these data together at real time, because all these data happening at real time. So there is no historical data, there is no machine learning, there is no optimization, there is nothing, just real-time data. So usually banking industries, they collect these real-time data and they have their own systems, right? They are those systems working at real time, and they take real-time actions in terms of news, and these actions and reactions through investors and and banks. So this is another example that usually banking industries, working with them. And if you look at in LinkedIn or other, job portals, there are huge demand of expert with, with this expertise that to be able to work with real-time data, usually banking. So they are really looking for this expertise. And as I said, financial institution track the changes in the stock market. Real estate website track a subset of data consumer mobile devices. So this is also available in Google Google advertisement section. I don't know, have you had any information or not? Ads.google.com. If you go through, these ads, you can have your own advertisement, and Google is going to ask you for what sort of, customers you want to have your advertisement, and you can select. For instance, you can say, I want to show my advertisement for people, let's say, around University of East London. So Google, how Google is going to find out? Google with the location, is going to use the location of mobile devices. And if, someone around University of East London is going to consider him or her, to provide this advertisement. These are really nice, topics, and also you can pick them, as your dissertation. In this case, we can work, with real data processing, and yeah, many more like online gaming companies. So they're gonna to collect, the player game interactions, how they work with keyboards, how they work, sometimes they work with camera. So they're gonna to capture, data from environment by face recognition, image recognition, and so on. And these are all, let's say, collecting at real time. And these companies should face with, these, sort of actions at real time. How to do so? They need to work with, new technologies like Spark. And as we said that it is better suited for real-time monitoring and response function. So we can't do, huge calculations, huge analytics over real-time data, because the real-time, the concept of real-time is there. Means this is real-time. We have it for a short time and we will lose it, afterwards. So these sort of data comes at a short time. We have to process and we have to action. So this is also similar to the notification like you get from like from your bank. If there is a fraud detection, if there is something wrong, they're going to send you a message at real time. How they do that? Because they have to collect all information at real time and then process and then send notification. And how to do all these things, we want to start from today to see how we can do that. So for batch processing, this is the big differences between batch processing and streaming processing in terms of, these four criteria. So for data scope, you can process, the whole data set, but for streaming, as I said, you have to get data portion by portion, time by time. You have no all data, at hand at let's say as batch processing. So data size usually large. There is no any limitation, but for streaming data, you have to consider kilobytes maximum, maybe 30, 40 megabytes. Again, it depends on your hardwares, it depends on your hardwares. If you have like a data center, like Google, like Microsoft, they have, data centers, they have very powerful memories. And in this case, yes, you can consider even the gigabytes data. So the size of data for streaming processing depends on, the hardware you're having. But by the way, the classical definition of a streaming processing is working with micro or micro batches or small size data like kilobyte data. You can consider them as a processing. So performance means latency can be minute to hour, means you want to run machine learning, to train your data. So how long does it take doesn't important, because for machine learning in particular, the accuracy is important, not the taken time for training. So, but for streaming data, we have to consider, second, even milliseconds, because we have to respond, quickly. And analysis, we can have complex analytics like optimization. We can have, feature selection, any kind of machine, because usually machine learning and artificial intelligence or any hybrid intelligent algorithm, they take, lots of times. So you can take them here on batch processing. But for streaming, no, we should have, simple like aggregation, monitoring, like simple response function, and so on. And if we go through here, as I said, we have two important layers: storage layer, processing layer. So storage layer is definitely memory, because the only available hardware that can take, a fast decision is memory. And also processing layer. The processing layer means the application, the tools, the system can process your data. And usually here we use PySpark. In this case, we use PySpark. Or also, if you are working with a Scala, you can use a Scala. If you work with Java, you can work with Java. So I will give you more information about this processing layer by next week, because there are really, ongoing nice platforms, working on this processing layer, because this area, this data streaming area is growing up, and it's really good to have well enough information about this part. And also huge money is there. If you look at the job specification and the jobs coming in LinkedIn or other job portals, really nice money, £600 per day, £700 per day as a contract. Even for for full-time jobs, even there is more than 70K if you have this expertise. So let's do start. So Spark is streaming. So Spark has lots of components like RDD, data frame, machine learning, and graphics for graph analysis. And another part of Spark, another component of Spark is streaming. So it means you can work on streaming. This is the whole idea of a Spark streaming, and this is the link. This is the source I'm using. And I will cover almost all these topics, within today and next week. And we will see how we can go through Spark streaming. After today and next week, if you're very interested on streaming applications, I highly recommend you go through, this guide, this user guide, and also I will give you other sources by next week, and you would have, well enough sources for data streaming. And you can take your dissertation with me about Spark streaming, or with other colleagues if you prefer to to work with anyone. So you can do it as your final dissertation, then you can build up your knowledge. My recommendation for all students is, since the most of you know about machine learning, so if you know machine learning, I highly recommend you try to challenge yourself with other topics, like with graph analysis, like with data streaming analysis, like with working with Hadoop ecosystems, Spark ecosystems. So, but if you are not really strong in machine learning, I highly recommend you to go ahead with machine learning, right? Try to pick your, pick the right decision, because it's really important for your future career. For data streaming, we need VMware. So you cannot work with Google Colab. So if you haven't, this VMware, please refer to week 1. I give you all requirement about, Ubuntu and about this VMware. You have to download it. You need that. And another approach of working as a group is, maybe someone has difficulties using with his or her own machine. So in this case, you can work with your groupmate machine on data streaming. And by the way, in KD Labs, and we have these Ubuntu machines. If you have no access to data streaming on your own local machine, you can use KD Labs. So password is Big Data admin. Okay, let's move on. Okay, it's really small, so let's go to setting and then scale it. So keep changes. Okay, perfect. Now we have it. Okay, here, okay, in desktop, this is streaming. So guys, these are source file. By the way, in Moodle site, I put the HTML format because I want you to copy or type the comments. If I give you this IPYMB, then you just want to run it, because everything is available. Just want to run it without any learning. So I put the HTML formats, and then you need to open the HTML files and copy, or let's say it's better to type. and then type to be able to, learn the syntaxes. So here I want to create a new folder. I want to name it streaming. So I want to go inside and paste those files and folders. Okay, just files. So open in terminal. This is what exactly you can do that. And here we have to type Jupyter Notebook. Great. So Jupyter Notebook is here. We want to start with this one, DStream, first one. So, but in your case, since you want to work this Monday, you have to come to new Python 3. And then here, since you have just HTML ones, then here you have to type the syntaxes. Which syntaxes? These syntaxes, starting from here. You have to type syntaxes. Or even you can copy paste. You can copy from here and paste it, there. But just for, learning purposes, it's better to type the syntax rather than copy pasting. Okay, so, okay, DStream or discretized stream, this is like a simulation of real-time data. What does it mean? It means here we can create several RDDs, right? And then we can send them to, let's say we can send them to the Spark engine at each time interval. Let's say the time interval is 1 second. It means the first second I want to send this one, the second this one, the third second, the fourth second. Each second I'm going to send, these RDDs. And it means when I get RDD at first time, I have to process. Then I have to, delete it, remove it, or ignore it. Then RDD at time 2, I have to get it, process it, ignore it. RDD 3, processing, ignore it, or means after processing, ignore it, means delete it, remove it, or whatever you want to do. So this is the stream. Let's say this example, converting a stream of lines to words, the flat map operation is applied on the RDD. So if you want to work with data DStream, this is, guys, very basic, right? This technique is really very basic, but it's good idea to start to see how we can work with that. So there are some syntaxes. So let's go through. Yeah, let me go through the code and then I can explain through the code. Okay, first of all, make sure to have find Spark. If you haven't installed it yet, you have to install it here. So let me run it. So, and then, guys, before we just imported this one, Spark context, but for streaming you have to have this additional library, pyspark.streaming, and you have to import streaming context. Before, we were working with Spark context. If you remember, it was SC, right? It was the driver. So now we have two drivers. One is the Spark context and another one is streaming context. So run it. So then you have to create a Spark context firstly, because we have to load Spark. So we have to load Spark. Here I can add only app name, so simple. And then this is SC, and I'm creating another Spark context that I'm calling Spark streaming context, SSC. So anywhere you see SC means batch processing. If you see SSC means real-time processing. So it means create a streaming context. Who is the engine? The engine is SC, means a Spark engine. And one is the time interval at which streaming data will be divided into batches. Means get data every 1 second. If you want to process your data every 5 seconds, just put it 5. 2 seconds, simply put 2, right? But here we think it's better to have it at each second. So since this is like a simulation, here I'm going to create How many RDDs here? I want to create, 3 RDDs with random data. So this is the random data. So can you see sc.parallelize? And then there is a for loop. I want to create the random data. So for those people working with Python, so random.sample is the is NumPy library. No, it's a random. No, this is a Python library. We didn't use NumPy. So this is a Python library, random.sample. It's going to say between 1 to 1000, create or generate 50 random values and divide them into 3 portions, right? Because I'm using SC parallelize. If you run it, not defined. Oh, because I forget to run it. So, okay, I'm creating. If you want to check what you have done, if you run it, RDDQ0 means the first bunch of data. It means I'm going to send this bunch of data, this bunch of numbers at the first second. Then if you added 1, means this is the second bunch, and so on. But if you want to read all data, if you remember, we had this comment, RD dot gloom dot take, or let's see, dot collect. Let me see if it does work. No, because we have to use. Okay, no worries. So if you check here, because I just want to show you what sort of data we have been generated. So if you remember here, I've said create 50 values. So the combination, all these values are 50 numbers between 1 and 1000. So, and then I asked to divide them into 3 partitions. So as you can see, this is 1 partition, this is 2nd partition, right? And this is 3rd partitions. So now we have an RDD in the first index of this list, including 3 partitions. And you can check all data, then, second data, and so on, right? This is the whole idea. So guys, as I said, this is simulation. It means I made 4 RDDs. I want to send them as the real-time data to Spark streaming. So let's see how to do so. There is a command, we say queue_stream. So queue_stream means get RDDs as a queue. And since we defined here to take each RDD at every second, means it's going to take a first RDD at the first second, second RDD second, the time second, and then third one as the third second, and so on. So now data is on the stream format here. Guys, the rest is like transformation. I want to map each second, get X divided by 10, and then the remainder, keep the remainder and put number 1 in front of that, and then reduce by K. It means I want to count, the values at real time. So if you run it, it's okay. How to start it as a real time? Here you have to say ssc.start, and then time sleep. I will tell you what is that, and also ssc.stop. So if we run, so as you can see, it's going to get those values, at each second, right? And it's going to have 5 second additional, because here I said take 5 second additional and then sleep it, and then, stop, and then stop it. So as you can see, at the first second, after getting, the first RDD, it says there are 4 items that the division by 10 is 0. There are 6 items that the division by 10, the division is 10, right? The division is 4. So the task is not important here. The thing is how to declare, this streaming. And as I said, this is like the simulation, and we usually don't use that, but for simulation purposes, we can use it, right? To see, how does it work. The most challenging part of this practice is starting by this one. Let me go ahead. QStream now with with window operation. This is really important. So window operation, it does happen mostly in reality. It means we have to collect data at a specific time slot and then process here. We have to process here, collect data at a specific time slot and then process here, right? This is what exactly really happens in, you know, in real cases. So to configure this one, we need to have two parameters, window length and a sliding interval. So window length is the length of, you know, your bunch of data. Like here is 3, number 3. And sliding interval means at which window operation we have to have the performance. Let's say to have the action. So two important parameters. Let's explain here. So, for instance, let's say here we said that the 10-second is the window size, is this one, is window length is 10, and sliding interval is 5. So sliding interval means every 5 seconds we have to have the action, right? So here, let's say I'm getting these inputs, this information as real-time data. So the first 5 seconds, I'm getting, you know, these 3 lines. So since we said that the interval here, the sliding interval is 5 seconds, means exactly at the end of 5 seconds, we have to have the action. What is the action? Action is to print out whatever you got, right? Type hi, this is a streaming class. So we have been started at this second. So then we still keep data, we still get data. The second 5 seconds we have this import. Here we learn big data. So this is the second 5 seconds. Can we see that this is second 0 to 5 and then 5 to 10. So again here we should have the action. So what is the action? Guys, this one interval, sliding interval, just tell us to when to perform the action. So as you can see that here, this is 41 exactly after 5 seconds, right? But what we have to action, the action is we have to collect the all window size. So what is the window size? The window size is, in this case, the window size is exactly this one, right? The 10 second. So the printout is 10 second. So again, the time interval, this one, sliding interval is going to tell us when to have action, and window length is the bunch of data we have to do an action. So what is the action here is just, you know, print out the real-time data. So let's continue. And then the third 5 second, I'm just getting, you know, one word. This is C, right? It means I have to have action here. So what is the action here? So I have to have action for the recent 10 seconds. So what is the recent 10 seconds? This is the recent 10 seconds, right? 2 5 seconds. And then I'm printing out those data here. Can you see that here? We learn big data and C. So we have to work with these two parameters, sliding interval and window length. So this is one example. Let's take another example. It's here. So what is the task? I want to count the number of words, right, in the DS string format. So again, I'm taking 10 seconds at the time window size and 5 seconds and the interval size. So after 5 seconds, we have to have an action. So what is the action? To count number of words, 1, 2, 3, 4, 5. So we have 5 words. Perfect. Here we have another action after 5 seconds. So what is the action? Count the number of words within the window size. So what is the window size? This is the window size. And we have 10 words. And so on, guys. You can go through this one after 5 seconds. It's going to take, you know, these 2 5 seconds as a recent 10 seconds. 1, 2, 3, 4, 5, 6. We have 6 words. And the last 5 seconds, we have this one, and which one is the window size? The last 10, or let's say the recent 10 seconds. It's see you soon, take care, right? It's a the combination is 5 words. So this is the combination of, time interval and time window. So any question about these 2 parameters? Because the rest of the practices would be on, on top of these 2 parameters, time window and time interval. Okay, it seems there is no question. So to be able to work with, any question? Okay, so guys, to be able to work with window operations, there are like several methods, right, that we want to practice within today. So one method called window, which is getting window length and a sliding interval. And as you can see that all of them getting window length and sliding window, like this one, window length, sliding window length, sliding interval, window slide, window slide, window slide. So all of them get these inputs. So yeah, 1, 2, 3, 4, 5, 6. We have 6 methods. Then within, using these 6 methods, and also we have more than 6 methods that I want to cover next week. So within these 6 methods, we can collect data at real time and process data. Let's do practice one by one. And let's learn a few things. So netcat or NC is a command line utility that you can read and write data across network connections. So if we use NC-LK, L means listen to the inbound connection, and -K means force server to stay up even there is no coming traffic. And also there is a port number. I mean, this is, like random port number. So why we need that? Because we have to collect data, real-time data from somewhere. So how to collect data from somewhere? We can use netcat service to collect data at real time. So let's do practice to see what is that. Okay, let me get back to here. Okay, I want to start with the first function, window stream. So if you open window stream, so it says return a new data stream which is computed based on Windows batches of the source stream. So let's see. So again, make sure to have this pyspark installed. If it's not installed, simply install it by uncommented. So since I have it here, you can do it. And then here again, these 2 libraries important. Guys, here, as you can see, I said master, means I should work with 2 cores of this machine. And app name. So set log level, I want to say please collect on only error messages, as a log file, because there are different kinds of log files like debugging error, fatal error, information, trace, off, warning, and so on. I want to say just keep the error messages, as a log file. And then streaming context, SC, and then 1. 1 means collect data every second. If you put 2, it's going to collect data every 2 seconds. Well, let's do it with 1 second. And then here we have SSC checkpoint. So as I said, SSC means Spark context. So means working with the streaming. Checkpoint, guys, checkpoint means, because for the streaming data, we need to make sure the system is 100% available. It means if there is any problem, any failure, any crash, any disconnection, right? We have to make sure we have still data. We have still the configuration for streaming processing. That's the reason we have to declare a checkpoint. Checkpoint means make your streaming application resilient against failure, right? In this case, if you have any disconnection, if you have any failure, if you have any crash, it's going to keep the track of all configuration you have been done, and after your system is going to be up, it's going to get back all information from checkpoint. So this is checkpoint is like the logging file. It's going to log your metadata. So it's configuration, the stream operation, and incomplete batches. So these are all relevant to Spark streaming engine. And also you can checkpoint data. So this is not really highly recommended because data checkpointing, it takes lots of storage, because let's say you want to collect data. If you want to checkpoint it, if you want to, to store it somewhere in terms of failure, maybe you need to consider hard disk in this case, because you have to keep data somewhere. So it is important for some really risky environments, like if you want to set up sensors somewhere that is a noisy environment, or if you want to set up, sensors somewhere that there are malicious, traffics, you don't want to lose your data. In these scenarios, yeah, why not to collect data somewhere? Maybe you can collect every 10 minutes of data. So for just failure, just to be, resilient against failure. So you can collect data every 10 minutes, you can checkpoint them. Means keep them for 10 minutes. And if there is no any failure, remove them. Again, keep another 10 minutes of data. If there is no failure, remove them, right? You can keep data step by step, but we usually use metadata like these information configurations, stream operations, and incomplete batches. So how to do so? It's really simple. It's really simple because here you just need to say .checkpoint. And then here you have to give the folder name. So this is just a folder name. You can put one, then it's going to collect all information in this folder. So I want to use checkpoint, as a folder. So, and if you run, so it's running. So can you see that, guys? We have folder checkpoint. This is a folder and it's going to collect those information. So for fault tolerance, so now, guys, we need the inbound traffic, guys, because we have to work with real-time data. So how to create the real-time data? The one way is to use netcat service. How to do? You can open new terminal. So how to run a netcat as an inbound traffic? You just need to type like this one. NC means netcat service. -LK means get data from inbound. Port, which port? I want to get port 7000. This is random port. And K means keep working, and keep getting traffic. Even this is the silent port. So if you run, so it's going to now act as the inbound traffic at real time. So here I'm going to say, please collect data from localhost, means this machine, from this port. So this port should be exactly this port. So if you run, SSC means your Spark streaming is going to listen to this port, to collect data at real time. And then it's going to apply this function. So use flat map, split them. If there is word Spark, return 1. If there is no, return 0. So let me highlight it. I don't need that. So as you can see, the window size is 10 seconds. The interval is 5 seconds. It means we expect to get result at every 5 seconds. So if you run, again, there is nothing. This is just the, this is just a function we asked to do. And SSC start. So if you run, so it's going to listen to this port, right? But this port is still empty, right? Can you see that, guys? It's going to listen to the port. Can you see every 5 seconds? Every 5 seconds is going to listen to the port and then complete this action. So now I want to start. Hi, everyone. So let's see what's going on here. It's going to listen. So it has been listened. We expect to get 2 zeros. Why? Because we said that if it's not Spark, return 0, right? So still 0 and 0. Why 2 zeros? Because this is first 5 seconds. This is the second 5 seconds. Because we said that the time interval should collect data within the window size. So if you say Spark, hi, Spark, for instance, if you see, can you see that number 1? Because there is one Spark. Sorry, this one. This is Spark. This is capital. and these are, you know, the information. And this one is gonna to generate, this netcat is gonna to generate real-time data for us. You can stop it, you can close it. And here, how to stop this real-time? By this stop. If you run, so what is stop Spark context means? Stop Spark streaming. I mean, we don't need that, means stop all components. Stop gracefully means make sure you get all the last minute data and then stop it. It's really important to have it. Stop gracefully. I guess I have it in the note, in the lecture note. Let me see. Yes, I have it here. If true, stop the associated Spark context means stop anything relevant to Spark engine. And stop gracefully means if true, stop gracefully by waiting for the processing of all received data to be completed. Right? These are really important. And let's get back to the practice. So here, guys, here, I mean, the action is exactly Spark coding, right? You can use flat map, reduce, whatever. So here I want to say use reduce to count them, right? I want to count. I don't want to print, you know, 1 0 0 0 0. I want to count them by calculating all together. So let's run again by adding this reduce function. So to run again, since guys here, since here we stopped Spark, we have to rerun it here from this part. We have to rerun it. And again, listen to this port and do these actions and SC start. So it's going to start, but still port is off. I can make it on. And then I want to type Spark. Here is like, I don't know, random input. Spark, hi there. So can you see that it's going 1 because we use reduce, and then 1 and 2. Guys, these are at each batch size. So 1 and 2, this is from previous batch and this is for current batch, and 2 means, you know, these two inputs, and so on. I can see that I have no any input, and if you stop it, can you see that it's going to make sure the last 5 seconds is still working and there is still data. So can you see that it's still working? Can you see? Stopped. Because since my inbound traffic hasn't been stopped, it's gonna to check if there is still input, get it. If it's not, then stop it. So it's better to stop now. So this is one way to generate data at real time using netcat. And we have another function we call count by window. If we go through count by window, it says return the sliding window count of elements. So it's going to count it by itself. We don't need to write reduce. So again, we have to make sure to use this one, find Spark, run this one. And this is, guys, another way to declare your parameters. Here, I use a Spark configuration, set app name. I said for the executor part, since everything is running on one single machine, executor and driver both are these, you know, this Ubuntu machine. By the way, if you have many machines, you can say the executor memory, I want to use 4 gigabytes of memory for executor, the driver 4 gigabyte. Guys, different way of combination. So here, Spark core, the maximum use 2 cores. But if you remember here, how we declare that? We're typing this one, master local 2. Either this one or this one, you know, is same. These are different way of configuration you can learn. And then compile all configuration. Here, set log level. These are all, I mean, the rest is same. Get data every second. And then checkpoint. Guys, if you add it 2, right, it's gonna be multiply this one. It's gonna be 20 and 10, right? Because I said consider the time interval means 1 second means the frame calculation would be 1 second. Then it's 10 second and 5 second. So let me run it. So I'm going to hear data again from this port. So if you are interested in like other data collection method like Kafka, so Kafka is another, I want to discuss about it by next week, but using Kafka, Kinesis, KStream, these are very nice data collectors at real time. They want to collect data from the producer side. They want to collect data from producer side, and then you can process your data here. At the rest, you can start processing your data. So here we use this, inbound traffic using, this port using NetGAP. By the way, you can use Kafka, Kinesis, KStream, and many more. So, and these are the topic for next week. I want to discuss about this one by next week. So let's firstly understand these methods. So now, what is the action? The action is use flat map for each lines. Guys, lines is here, right? We got lines at each interval. So lines.flatmap, split them. And once you say count by window, it's going to count how many words is there because we split them, right? So how to do so? Use the window size is 10, the time interval is 5. Guys, we don't have print here, we have pprint. For data streaming, you have to use pprint. Then we can print, result here. So let's do so, run, and then start. So again, I want to start this port. So I want to say, hi there. I'm going to slow down my typing. This is class running. So can you see that it says the first of all, we had 2 words because the function is count by window. Can you see that, guys? Window is going to count based on each window. This practice we did is going to count per window, as it really needs practice. Can you see that? Then we have 7, we have 5, and then we have nothing because we stopped sending input. So, and as you can see, it's going to get each data at every 5 seconds. Can you see that? 9, 14, 19, 24, 29, because we asked to collect data, or let's say to process data every 5 seconds. If you have nothing, you can close your, your port, and also here you have to stop it, run it, and it's going to check the last interval, time interval, and if there is nothing, it's going to stop it. So whatever about this one, reduce by window. So if we work with reduce by window, return a new single element stream created by aggregation. Guys, reduce, we practice week 2 and week 3 together. So reduce is going to aggregate the result. So how to aggregate the result? We need to have a function, means the aggregator, and then window length, sliding interval. Really simple. So let me do so. Run find Spark, run this streaming, run these configurations, listen to this port. So I want to run the port. And then this is the function. So what is the function? I want to calculate the average. So here, let me run line.flatmap. So we usually use that because we have to split the words, right? I'm saying split the words, and then numbers is, the RDD, numbers.reduce by window. So when we say reduce, we have to, specify the function. Which function? The function is this one, calculate the average. So then we have inverse reduce function that I will explain what is that. Window size, again, we're still using 10 and 5, and then pprint. So let's see what's going on. Run it and then run it. So I want to say 1 and 3. So the what is the mean calculation is 2, right? 1 plus 3 divided by 2 is 2, right? So you can add number like 24, 4.5, 1.2, 1.1, I don't know, whatever, -4 and so on. and it's going to, to calculate the average at each time interval, calculate the average. So because we used reduce by key, right? Sorry, reduce by window. It's going to aggregate the result at each window. So, and then you can stop it, stop. And also you can stop this one here. And another function is count by window. So count by window is going to, it's going to get window and slide interval. And guys, this is count by value and window. So before that, we had count by window. What does it mean? It was going to count all values within the window size, but this is going to say when called is going to create a pair, key and value, right? And return a new data stream. Let's see how does it work. So run again, run again. So these are the configuration. You can run. Listen to this port to get real-time data. This is the function. Again, I'm using flat map to split data. So we usually use that, guys. We usually use flat map as the first, function. And then the actual contribution here is count by value and window. So if you run, let me run. I'm going to say hi, welcome. Let's see. Oh, I didn't run, so let me run. So can you see that it says there are 2 highs and 1 welcome, because we said that counts them, right? Again, hi, here is CN730, CN730, for instance. As you can see, hi is 1, here is 1, ease is 1, is going to count. And then CN7 is 2, right? Because 1 came from previous time interval, this one, and another one came from the new time interval. Guys, really simple. You just need to practice. The concept is, the way of data collection is different. Before we try to use the batch file, but here we are working with streaming data, means real-time data. So this is one way to collect real-time data. Let me make sure if there is any question. Any question? Let me double check the time. Oh, we are closing to the session. Okay. How did you find it, guys? How was that? I guess you need to practice. If you practice with these, combinations, generate real-time data and then process data, you would understand. So also I'm recording the session. You can, rewatch the video and then you can practice. Any question about these functions? We went through 5-6 functions to see how we can work with them. Okay, let me see what else is left. Okay, we have here inverse function. So guys, inverse function, we have to use it somewhere in these 2 methods. Within usually these 2 methods, reduce. Inverse function is here, but also we have inverse function for this one, but because in Spark version 3, we have inverse function also in this method. So what is that? Guys, if you remember here, we consider 2 time interval for, for action. With inverse, we can set that for the previous 5 seconds, you can ignore it, or you can do whatever, whatever else. What does it mean? It means, let me go back to here, and I guess we have another function. No, I didn't bring it. So maybe I want to, yeah, we can practice it next week, I guess. Yes, it's not here. Okay, by the way, let's leave it for next week. I didn't put it here. Okay, let's leave it for next week. So by Monday, you have to practice these 5, functions. Let's say these streaming applications. And we have, guys, these are at the back end. I mean, we as a developer, we have to develop these applications. But the question is how we can use them as an endpoint system, how we can use them, as an exe file. So let me open this streaming. Is here, right? So PySpark sample, let me open it. Guys, this is if you want to convert this code as as an exe file, you have to put all together in one single Py format, .py. So here we have to load the Spark, we have to link with the Spark, we practice. So the only difference here is you have to create a main function in Python, right? And then put whatever you want as your code inside this main function. So for instance, create a Spark configuration, set the application name, how many cores you want to use, and then input integer. Here I have 5 inputs, and this is the action. And let's say I want to visualize it. If you want to visualize it, you have to work with Python visualization libraries. Like tkinter. I'm not sure if you're working with this Python visualization library or not, but at this stage you need to have your own skill set for Python. But I want to give you, the ideas to how to work with that. So really simple. You just need to copy your all codes from, this environment, from this, like from this one, these all codes, right? These syntaxes into one single file, and then you can simply execute. How to execute? New terminal. If I say Python 3, right, and then PySpark sample. If we run it, and then it's going to say product is 120. This is the action we ask. Also, we ask to print out as the user interface. So you can simply, convert it to the exe file. Even for this streaming one, let's have a look. This is streaming. Again, find Spark. So let me see which one is that. This is reduced by window. So let me open reduce by window. This one. So let me kernel restart. Okay, find Spark. This is what exactly I have here, right? And then since I want to get input, right, from end user, because I want to get real-time data, here I have to import system, and then these two I have them here, right? And then the rest I have to put it in the main function. Here I use the function called def. This is a Python function, and then here I said if name is main, and then run the main method, this one. These are Python. So these are all combination, all configuration that we did here, right? And then what is the action? The action is this one. Where is the action? This is the action. I just copy pasted. And there is another difference. Here we use this one that we can manually stop the, Spark engine. But here you have to use this one, SSC await termination. It means if you close the application, it's going to stop it. It is when we have to use for, end systems. So let's run. So PySpark, what was the name? Streaming. Okay, before running, we have to, we have to open the port. So let's run. So can you see that it's waiting for input? Can you see that, guys? We have no input, but if you say 1 and 3, it's going to, generate output. Right, is 4 because we said that counts them. 3, 4, 5, I don't know, let's say 9, whatever. And then you can get output here, and then this is like the terminal output. You can have your Python skill and have it like a user interface output.